Welcome to the zero-degree mystery. We always thought Antarctica was a biological desert, but beneath kilometers of eternal ice lies a secret that defies biology. Complex life that, according to all our models, shouldn't exist. Creatures that thrive in darkness, cold, and pressure. Today we are going to dive into the Larsen C ice cavity and see how these findings force us to rewrite the rules of life on Earth and in the universe. If science is your passion, leave your like and subscribe so you don't miss this icy expedition. Antarctica, that white and desolate continent, is the last virgin frontier of the Earth. Its icy immensity, a landscape of white and blue stretching to the horizon, hides beneath its ice shell the record of millions of years and, even more astonishingly, ecosystems that defy all biological logic. For a long time, it was believed that life on the southernmost continent of our planet was either coastal and dependent on sunlight or completely impossible in the subglacial environment, buried under kilometers of eternal ice. The premise that finds under Antarctica that shouldn't exist resonates with a mix of scientific adventure and cosmic wonder. It is not about myths or legends of lost civilizations, but about the tenacious reality of microbial and multicellular life that thrives in darkness, extreme cold, and pressure. Science has recently opened a window to this subglacial world, revealing a hidden biosphere whose existence questions our understanding of the planet's habitable limits. The discovery of complex organisms, similar to jellyfish or anemones, living in ice cavities hundreds of kilometers from the open sea, is a milestone. This life not only survives but flourishes, forcing us to reconsider where and how life is truly possible. To understand why these findings are so revolutionary, we must first dimension the environment. Antarctica is not just a block of ice, but a vast and complex network of glaciers, subglacial mountains, and, crucially, floating ice shelves. The epicenter of one of the most surprising findings is located beneath the Larsen C ice shelf, a floating ice extent larger than some countries. Beneath these platforms, the interaction between meltwater and the ocean creates a hidden landscape, subglacial cave and cavity systems. The environment inside these cavities is a biological hell according to surface standards. There is absolute darkness, as sunlight, the energy source for almost all life on Earth via photosynthesis, is completely non-existent. The constant and extreme cold keeps the water temperature right at the freezing point, typically minus 1.9 degrees Celsius, an environment that demands extreme physiological adaptations. The pressure is intense, as the weight of thousands of meters of ice and water creates a force that would crush most creatures we know. Finally, the isolation is total. Life here is separated from open marine ecosystems by hundreds of kilometers of solid ice and confined water, creating a sealed chamber isolated from the surface world. Traditionally, marine biology established that only very simple life forms, bacteria and archaea, could survive in such conditions, possibly feeding on the energy released by the oxidation of chemical compounds, chemosynthesis. The idea of finding multicellular organisms with complex structures actively moving and feeding in this abyss was, until recently, a science fiction fantasy. Despite these prohibitive conditions, life was revealed thanks to extraordinary engineering and perseverance on the part of the scientific community. The discovery of this impossible life was not due to luck, but to the use of cutting-edge technologies to penetrate the ice barrier. This required hot water drilling, a laborious process where high-pressure hot water jets are used to melt and open a hole through the dense layer of ice to the water in the cave below. Once the hole is opened, small, remotely operated vehicles, ROV, equipped with high-resolution cameras and sensors, are deployed to navigate in total darkness. It was during one of these missions, specifically the one led by the National Institute of Water and Atmospheric Research of New Zealand, NIWA, that they managed to penetrate a cave system under the Larsen C ice shelf. The initial objective was to measure the temperature, salinity, and other physical parameters of the water, but the images that began to arrive on the surface exceeded all expectations. The team of scientists, astonished, saw a vibrant ecosystem on their screens. The cameras revealed a visual feast in the darkness, a community of organisms clinging to the cave walls and swimming in the murky water. The reaction was one of astonishment and euphoria, mixed with disbelief. The images were clear. Complex life existed and thrived in a place where, according to biogeographic models, there should have been nothing but silence. It is incredible how these organisms, living in total darkness and under monumental pressure, have managed to prosper. This finding forces us to question everything we thought we knew about the habitable zone of a planet. Do you think there are larger subglacial oceans in Antarctica waiting to be discovered? What if this life has an adaptation we could use on Earth? Leave me your opinion and questions in the comments. And if the resilience of this life has blown your mind, support me by giving a like and sharing this video. The images immediately revealed the great challenge. The life found was not simple. The most striking finding, and the one that gives the greatest weight to the premise of this essay, was the identification of complex marine organisms, notably a new species of cnidarian that some described as a jellyfish-like creature or an anemone. These multicellular organisms are proof that the subglacial environment is not sterile, but the real enigma was how they feed. Almost all ecosystems on Earth depend on photosynthesis, the conversion of sunlight into energy by plants or algae. Without light, this food chain collapses. There are two main theories about how this hidden biosphere is sustained. The first is chemosynthesis. Like deep-sea ecosystems living near hydrothermal vents, this life could rely on bacteria that oxidize chemical compounds, such as methane or hydrogen sulfide, released from the underlying seabed. This chemical energy then forms the basis of the food chain, a true subterranean feast. The second and most widely accepted theory for the organisms discovered under the Larsen C shelf points to an allochthonous external food source. It is possible that organic matter dragged from the open ocean, dead plankton, marine creature feces, travels hundreds of kilometers, driven by ocean currents under the ice shelf until it reaches these caves. The discovered organisms, many of them filter feeders or scavengers, would be perfectly adapted to capture this biological stardust arriving from afar. The discovery of cnidarians, which are predatory or filter-feeding animals, and other benthic organisms living on the bottom, confirms that the food chain is not limited to simple bacteria. It is a dynamic and adapted system where survival demands extreme patience and maximum energy efficiency. This life teaches us that darkness is not synonymous with death, but simply a different way of life. The implication of such a robust ecosystem in the dark goes beyond marine biology. Its implications extend to astrobiology and our view of the universe. The existence of complex life under the eternal ice of Earth is a powerful testament to biological resilience. If multicellular organisms can thrive hundreds of kilometers from the open sea without light and at sub-zero temperatures, this dramatically changes the definition of a planet's habitable zone. Antarctica, in this context, becomes a direct analog of icy moons in our own solar system, such as Europa, Jupiter's moon, and Enceladus, Saturn's moon. Both moons harbor liquid oceans hidden beneath thick ice crusts. Until now, the search for life in these worlds had focused primarily on the possibility of microbes. The Antarctic discovery suggests that if life arose in these subsurface oceans, it could have evolved into complex forms, including marine invertebrates. Antarctica is therefore the Europa of Earth, a natural laboratory for designing missions that seek extraterrestrial life. Furthermore, this hidden biosphere has critical relevance for understanding the climate. The Larsen ice shelf and others like it are undergoing rapid melting due to global warming. With the collapse of the ice, these isolated ecosystems will be exposed to the open ocean and could face a mass extinction, or conversely, be released and integrated into the marine biosphere. Studying the biodiversity of these caves now allows us to establish a baseline of life that would be lost before we fully knew it, giving scientific urgency to Antarctic exploration. Ultimately, the finds under Antarctica that shouldn't exist are a humbling reminder that, despite our technological advances, Earth remains a planet of deep secrets. Life, that unstoppable force, has found a way to thrive in an environment that is, in essence, alien, cold, dark, isolated, and under crushing pressure. The discovery of cnidarians and other organisms in the subglacial ice caves of Antarctica not only confirms the tenacity of life, but gives us new hope in the search for life beyond our world. The forensic science that solved the Romanov mystery taught us to seek the truth in genetic details. Antarctic exploration teaches us to seek life beyond the boundaries of sunlight. What we find under the eternal ice of Antarctica are not just fascinating creatures, but proof that life operates with an ingenuity and adaptability that surpass our imagination. The universe of habitable possibilities has expanded enormously, and all we had to do was look down beneath the last white veil. The discovery under Antarctica not only gives us new marine neighbors, but makes us a direct analog of icy moons like Europa and Enceladus. Life is much more resilient than we imagine. Do you think there are microbial civilizations waiting to be discovered in other icy worlds? Leave me your opinion in the comments. If you enjoyed this subglacial adventure that expands the limits of science, please share this video. Thank you for watching, and don't forget to subscribe to continue exploring the impossible.